Hello, welcome again to the online video lecture series Essentials of Matlab. I am Suraj Kamya. So this is chapter 3, that is the programming in Matlab. So these are the contents of this chapter 3. Basically, first we will see the M files. Actually, M files are of two types, the function file and the script file. So the files we will be using is having the extension as a .m. So .m means Matlab files. The next topic is user-defined functions, and we will also see some of the inbuilt functions, the type of inbuilt functions. After that, from the part 3, we will start programming in Matlab, that is a conditional statement, flow control, more about loops, and some other programming commands. So let's start with the first part, that is the M files. This is Matlab's environment. The main disadvantage in working with command window is when you are having multi-line program. Suppose if you are having a program of 20 lines, then if you want to change the particular line, suppose you want to change the second line, then you cannot change or you cannot edit the particular line. You have to rewrite the complete program again, and you will again execute the whole program. And the second disadvantage is you cannot save that program in a file so that you can share or you can edit on later points. So to remove this kind of disadvantages, we generally use the script files. So to open the script file, you can either click on the new script button, or the easiest way, you can just write edit and just press enter. So basically this is the script file. So the programming is same as we do in the command window. The style is same. So let's write some commands. So if you are writing x is equal to 5, and if you are writing 1y is equal to 6. Okay, this is a very interesting thing with the script file, or we can say editor window. So as we know, the variable naming is wrong here. We cannot start the variable name with this numeric. So you have to start it with the alphabetic character. Okay, so it is also showing you the error as in red color. So it's indicating that your line, or you can say your particular syntax, is wrong. So if you correct the particular syntax like y is equal to 6 and just press enter, then you can see this icon becomes green. It means there's a no warning or no error. So let's write x plus y. Okay, now its color is in orange, so you need not to worry about the orange color, because orange color only shows the warning. So it is showing that you haven't used the semicolon to suppress the output, because in this case we want to show the output. That's why we haven't used the semicolon here. So to run this particular program, you have to first save this file. When you are saving the file, the name should not be having any kind of space, and the name of the variables and the name of the file name are sharing the same rules. So let's suppose we are saving it with Untitled 3. Let's save it. Okay, so we have saved our file. So if you want to run this program, either you can click on run button, as here we are having the result, or either you can just write the name of the file, so it will be executed. Okay, so this is the file we have written just right now. So let's close this file, and in the current directory it is saved as untitled.3. Here is our file. So you can anytime just open the file and you can change whatever you want to change. Okay, so just run this program. Now we are getting the negative results. Okay, so this was all about the script file. So I will be describing all these functions in the later chapters whenever it is required. So let's just move to the function file. Okay, so before defining the function file, there are some concepts which you should know about the function file. So first thing is, what is the input argument and what is the output argument in case of function. Okay, suppose we are having loads of inbuilt functions, and we can also create our function, that is called as the user defined function. If we talk about the inbuilt functions, then we are having loads of function in Matlab. For example, suppose here we are having the function pwd, clear, clc, whos, numel. Okay, so here in this figure, actually the different kind of functions are given. So let's analyze these things. So the functions are organized in the way of number of input arguments and number of output arguments. So we can have multiple input and output arguments, and we can also skip the input and output argument as we want. So these are all the possible cases, and these are all the examples related to these cases. Suppose in this case we are not having any kind of input argument, the input that we will be providing to the particular function, and according to that input it will execute and give you some output, and output will also be stored in a particular variable assigned by you. So but you haven't described, or you haven't defined any variable here. So we can say the number of output argument is 0 and number of input arguments are also 0. So for this, examples are CLC and clear. So these are the comments. Okay, there's a one more thing, you can specify the comment in the editor file and the function file using the percentage. Okay, so similarly I have written in the same format. So if you're using the percentage, the comments will be in the green color. So CLC and clear are some functions where we do not use any kind of input and output argument. So let's see some more example. So if you are having numal, in this thing you are having one input argument, you are providing x as the input to the numal, and the output you are having in the variable capital N that is defined by you also. So numal is the function basically for the number of element as already described in the chapter 2. So in this thing we are having one input argument and one output argument. Okay, so let's move to some another case, like we are having multiple output arguments and multiple input arguments. For example, XLS read. Okay, so UI get file and XLS read are both are the new function for you. So I will define these functions also, but from just right now, just keep it in mind that UI get file is used to browse the file from any location, and in the return it will provide you the file name and the path name. And XLS read is used to read the Excel file. Suppose my file .xls is the my file name, and we want to read the data from sheet 1, and this is the range of the file A5 to F5, range of the columns that we want to read the data. And these are the output arguments. The data of the file will be read it in these arguments. Okay, so we are having a number of functions here, and we can say kind of different kinds of functions according to the output and input argument. Okay, so let's move how to define your own user defined functions. So let's just move to the Matlab again. Okay, so to define the function file, you have to again open the script file. So the way to open the script file is to just write edit. Okay, so this is your script file, and actually the function file and the script file are the same. The only difference is you are having the three rules to define the script file as a function file. So first rule is, when you are having a script file, then to make it as a function file, the first word must be function. So this is your keyword which defines that this file is as a function file. Okay, now you have to define first the output arguments, then the name of the function, and then the input arguments. Suppose we want to add two number and we want to define of our own function, that is suppose my add. Okay, so we are adding two numbers and result will be shown in the one variable. So the number of output argument required for this kind of function is 1. So I am writing z is equal to my add, this is my function name, and here you can write a comma whatever x comma y, these are the input arguments, and just press enter. Okay, so this is the function definition, and now you have to define the processing of this function, that the processing with the input arguments. So we are adding the two numbers and the output is in z, so simply write z is equal to x plus y, that's it. So we can say our function is complete. So we have created our function. Now the second rule, because we have defined only the first rule, the first rule is the first word must be the function, and second rule is when you save this file, then the name of the file and the function name must be the same. This is the function name and the file name must be the same. So let's just save it. Okay, so this is our function, Now the third rule is when you are calling this function from the command window, then the function must be present in the current directory. So our function is present in the current directory. This is our function my add. So suppose if we are having a is equal to 4 and b is equal to some another number 7, and let's calculate c is equal to a plus, oh sorry, my add a comma b. So here is your answer, the addition of the two numbers. Okay, so there is a very basic differences between the script file and the function file. So let's explore the difference. So the last time we have created a file named as untitled 3. So let's just move to that file again. So this is untitled 3 file. Okay, and now in this workspace we are not having any kind of variable. Okay, so this is our script file. So let's just run this file. Okay, when I'm running this file, so I'm using three variables, okay sorry, two variables here, x and y. So when I run this program, the variables used in the script file is also defined in this workspace. This is called as the basic workspace. Okay, so let's move to the function file and let's see what happened with the variables. Now we are again having the empty workspace, and in the our function file we have defined the z, x and y. Okay, so I'm not using that variables. So let's just write a is equal to 4 and b is equal to 7, and let's just write c is equal to my add a comma b. Okay, this is our result. When you call this function, the only three variables are in the workspace. Okay, if we analyze the function file, so in the function file we have used z, x and y. So why these variables are not defined in the workspace? So it is quite surprising. So basically every function file have its own temporary workspace. So just keep it in mind and keep this concept clear that every function file has its own temporary workspace. So whatever the variable you are using in the function file will be the local to that function file. It will not be defined in the workspace. Okay, there is a very fair reason behind this, because you are using a lots of inbuilt function and you will be creating lots of user defined functions. So when you will be using the functions, you don't know what are the variables used in that function. So if the variables of the function file and the basic workspace interact with each other, or we can say the variables you don't know what are defined in the function, they can interrupt with your results, or they can we can say they can corrupt your result. So to remove that kind of errors or that kind of chances, we have just created like function is having its own temporary workspace. Okay, so I think is it clear? So if you want to define the multiple arguments, multiple output arguments for this function, yes you can do. So to define the multiple output argument, you have to use the square bracket. Suppose I want and subtraction also. So sub is also a variable, we can say output argument. So let's write the command sub is equal to x minus y. Okay, so now this function is having two output argument and the two input argument. So let's just call this one uh, e comma f is equal to my add, and let's write a comma b. Press enter. So these are the addition and this is the subtraction for that particular number. Okay, so in this way you can define number of output and input arguments. You can also change the number of input and output argument as required. Okay, so there's a one more concept that you can define the multiple function in the same file. Okay, let's see how to define the multiple function. Suppose I want to use the subtraction, but I don't want to define the operation in this function. I want some another operation, or we can say I want some another function to define this operation. So let's just write one more function, and suppose I'm writing sub here and my subtraction, and you can write a comma b, and let's write sub is equal to a minus b. Okay, so it is not compulsory that you should have the same name of the argument. You can change this argument name also, like if I am using to clear this confusion s1. Okay, so this is not mandatory, s1. Okay, now you can call this function my sub from this function. So you will be writing sub is equal to my sub a comma b. Okay, let's save this thing and now let's run again. So okay, we have cleared the variables. Just wait. Okay, so in this thing we have defined the x, y, and we have called here a comma b. That was an error. So let's write again x and y, because for this function there was a no variable defined as the x, sorry, a and b, because this is the temporary workspace and it do not interact with the basic workspace. So now this program is right, and just let's run it again. Okay, so here are the results: subtraction 11 and minus 3. Okay, so let's move to the function file. Okay, so let's see how this function works. So according to the three rules of the function, that the name of the file must be same as the function name. Okay, but we have defined one more function here. So how you can call this function outside this function, because we have called in this same function. So the question is how you can call this function from the command window, and the answer is you can never call this inside function, that the sub function, from the command window, because this function is only known to this function. Okay, and there's a one more thing, that the workspace of the function my add and the workspace of the function my sub is also different. They are also having different temporary workspace, even they are in the same file. That is a specialty of the function, that every function you write will be having its own workspace. Okay, okay, so here is the review of the script file and the function file that we have studied until now. So thank you very much. This was the part 1 for the lecture 3, and in the next upcoming part we will be doing the programming in Matlab, that are the conditional statements and the loop control and other programming commands. Thank you very much.